In this video, we are going to learn about significant digits. Significant digits tell us the accuracy of a measurement. You do some measurement, you make some calculation, and you report a reading. The person reading your result must know how accurate your readings are, up to how many decimal points, how much accurate is the reading. No measurement is exact. We measure the length of this object using this scale. We find that the reading is between 10.1 and 10.2. So what is the exact reading? We cannot say 10.1. So we make a guess, and I say the reading is 10.16. Somebody else may say the same reading is 10.17. It is just an estimate. Some third person may say this as 10.15. So this is the accuracy of this measurement, and significant digits convey the accuracy of our measurement. The number of digits in the measured value about the accuracy of which we are sure, plus one more digit, doubtful digit, are called significant digits. So I can say the length of this object is 10.16 centimeter. The whole world knows that this reading is accurate up to 2 decimal point, and this reading has got 4 significant digits. Now there are certain rules we follow for significant digits. First rule, all non-zero digits are significant, right? If a reading is 1, 2, 3, 4, 5, how many significant digits? 5. Simple. Second rule, all zeros between non-zero digits are significant. For example, if a reading is 4005, how many significant digits? No, not 2, it is 4. These zeros are significant, and these zeros are called confined zeros, right? Because they are confined between 2 non-zero digits. Next rule, all zeros to the left of the non-leftmost, all zeros to the left of the leftmost non-zero digit in a number with or without decimal point are not significant. You may think I have said something wrong, but let us look at this in more detail. If a reading is 0, 0, 0, 1, 2, okay, you say the number of significant digits is 2 because you know these zeros are totally useless. But if the number has a decimal point 0.013, this 0 is important as far as the reading is concerned, but this 0 is not showing the accuracy of the measurement. Therefore, this 0 is not significant. Remember this, zeros on the left are never significant. Whether the number is decimal point or not doesn't matter. Zeros on the left are not significant. Zeros on the right, if the number does not have a decimal point, zeros on the right are not significant. 4300, this has got 2 significant digits. Those zeros are not significant. Now there is a special case where the 0 at the end, if it has come from an actual measurement, then that 0 becomes significant. The zeros are just to show the accuracy of the measurement. If 0 has come from measurement, then that has to be significant. Suppose the height of this building is 410 meters. So this 0 is significant, right? And by chance the reading is having 0 at the end, So to take it as a significant digits, so when we are sure that this 0 has come from an actual measurement, we take it as significant. This has got 3 significant digits. If the number has a decimal point, zeros on the right are always significant. Right? Sometimes when a teacher dictates a question to you and he says the length of this object is 5.00 meters. Then you may think, why write 0.00? What is the use of that? These zeros are there to tell the accuracy of the measurement. These zeros are significant. So please understand that zeros on the right are significant if the number has a decimal point. So 5 is different from 5.0, is different from 5.00. This has got 1 significant digits, this has got 2 significant digits, this has got 3. Right? So zeros on the right are significant if the number has a decimal point. What happens when you change units? Suppose you convert from meter to centimeter. Say a reading is 2 centimeter and you convert that to meters. 2 into 10 to the power minus 2 meters. The accuracy does not improve. Therefore, change of units does not change the number of significant digits because the reading is not becoming more accurate by changing the units. Now when we write scientific notation, there is an exception to all these rules. If I write a reading as 2 into 10 to the power 5 meters, this has got how many significant digits? Just 1. That's simple. If you write this as 20 into 10 to the power 4, you may think this is same as that, but actually this has got 2 significant digits. This 0 here becomes significant. Suppose this is written as 200 into 10 to the power 3 meters. Then this has got 3 significant digits. So this is the exception for scientific notation. Now we'll discuss rules for rounding off. There are again some rules for rounding off. Some of you have learnt earlier. Now we'll discuss in more detail. First is simple rule all of you must be knowing. If the digit to be dropped is less than 5, then the preceding digit is left unchanged. Suppose we have got a reading 8.53 and you have to drop 3. You have to round off to 1 decimal place. This will become 8.5. The simple rule all of you have learnt in school, very simple, right? If the digit to be dropped is more than 5, like 8.57, then the preceding digit is increased by 1. So 8.57 will become 8.6. Very, very simple. If the digit to be dropped is 5, followed by digits other than zeros, that means a little bit more than 5. Okay, say 8.512. So the digit we are dropping is 5, but after that the digits which are different from zeros. Then the preceding digit is always increased by 1. Now when it is 5 or 5 followed by zeros, it becomes a little bit tricky. Suppose it is 8.55. What will it round off to? If you round off to 1 decimal place, 8.55. So 5 is here. This is an odd number. So if an odd number is there, we increase it by 1. Pay attention here. This is the only thing you have to be careful about. When we round off 8.55 to 1 decimal place, we look at this number. If it is odd, we increase by 1. If it is even, we leave it unchanged. You may think, why this kind of rule? People have made this kind of rule because we like even numbers more. Just like that. Okay. So this is the rule. If it is odd number, increase by 1. If it is even number, leave it unchanged. These are the rules of significant digits. Now whenever we are doing any mathematical operations, we have to take care of these significant digits. There are different rules for addition and subtraction and multiplication and division. First we'll learn the rule for addition and subtraction. Suppose we have to add up 1.2 plus 3.45, 6.789. Right, you may think this is very easy. Why are you doing this? Let's do that. Suppose we add up first 9, 13, then you get 4 here, then you get 11. So this is the sum, right? So you may think the answer is 11.439. This is not the sum. We have to take care of significant digits. This first reading has got only one significant digit after the decimal point. The second one has got 2 significant digits after the decimal point. And the third one has got 3. So which is the least accurate reading? Obviously the first one, right? So 1.2 has got only one significant digit after the decimal point. Our final result should also have the same number of significant digits, 1. So therefore the answer will write this as 11.4. So the rule for addition and subtraction is, look at the number with the least number of significant digits after the decimal point. The final answer should also have the same number of significant digits after the decimal point. So this was the least accurate reading, only one significant digit after decimal point. Final answer is 11.4. Now there are two ways of doing this. First we can do the addition and then do the rounding off. That is what many books follow. Some other books first do the rounding off and then do the addition and get the result. In most cases both the methods will give the same answer. In some cases the answer may be different. This is a better method. This is followed by the book Rationing Holiday. So we will follow this method. Now what is the rule for multiplication and division? When you multiply or divide, the decimal point can run from here to there. So then we don't look at the decimal point at all. We look at the number of significant digits without bothering about the decimal point. Suppose I have to multiply 1.2 into 36.72. Now this has got 2 significant digits. This has got 4 significant digits. The final answer should only have 2 significant digits. Overall, don't bother about decimal point in multiplication and division. So this has got 2 significant digits, 4 significant digits. The lesser one is 2. Final result should have 2 significant digits. We divide also 1101 by 10.2. Then this has got 3 significant digits, the denominator. The numerator has got 4 significant digits. So final result should have how many significant digits? Right? 3. Yes, the smaller one is 3. So final result should have 3 significant digits. So when you are multiplying or dividing, don't worry about the decimal point. Look at the number with the least number of significant digits. The final result should have the same number of significant digits. Now there are certain exceptions. Exceptions for exact numbers. 1 feet is exactly 12 inches. So these exact numbers can have as many significant digits as the calculation requires. Suppose you have got a reading of 26.98 inches. You want to convert this to feet. So we'll divide it by 12. Right? And what will you get? 2.4833. So how many significant digits should we round off the final result? You may think this is 4 and this is 2. But that is not correct. Why? Because this 12 is exact. 1 feet is 12 inches exactly. So that can have as many significant digits as our calculation requires. So this has got infinite number of significant digits. So our result should have only 4 significant digits, not 2, because this 12 doesn't matter. So now we'll round it up to 4 significant digits and we'll report the result as 2.483 feet. So in this video, we have learnt about significant digits. The important things that we have learnt are, first thing, all non-zero digits are significant. All confined zeros are significant. Zeros on the left are never significant. If number is a decimal point or no decimal point, doesn't matter. Zeros on the right are significant if the zero has come from an actual measurement or if the number has a decimal point. Change of units does not change the number of significant digits, right? There is an exception for scientific notation. So whatever we write as 10 to the power, that is not significant. Remaining digits become significant. Whenever we are adding or subtracting, then we look at the number with the least number of significant digits after the decimal point. The final result also has the same number of significant digits after the decimal point. When we are multiplying or dividing, then we look at the total number of significant digits without bothering about the decimal point. And whichever number is having the least number of significant digits, the final result has got the same number of significant digits. If there are exact numbers, like 1 feet equal to 12 inches, then the number of significant digits in these exact numbers does not matter. Exact numbers have got infinite number of significant digits. So just look at the other numbers in the calculation and give your result accordingly. So this is about significant digits. Thank you.